Hey guys, so welcome back. This video is to tell you about Riemann sums. And one of the first things I want to do is teach you how to pronounce this guy's name. It is pronounced Riemann. If you pronounce it Riemann or Riemann or whatever, I will kick you out of the math party forever. Respect the man, pronounce his name correctly, Riemann. So basically, here's what Riemann sums allow you to do. What if you had a weird shape and you wanted to find the area under the graph? So we know that this is an integral. Now, in the last video, we talked about how to estimate with triangles and circles and rectangles, but this is not like that, right? You can't find this area just by one of those common shapes. So what we're going to do is we're going to use rectangles to estimate this area. And of course, the area I'm talking about is still the area under the curve that we were trying to find, so that's just this area in here. Okay, so let's go. So we can estimate the area basically by drawing rectangles. Remember, the formula for the area is base times height. So what we're doing here, we're trying to go from 0 to 8. So what I'm going to do is I'm going to do two rectangles. I'm going to do this two ways. First off is going to be the left-hand point. So what I'm doing here is I am using the height at the left side of each interval. So I'm splitting this up. I'm splitting this up into two different intervals. So I'm going from 0 to 4 and then 4 to 8. So from 0 to 4, that's my first interval. So I'm going to use the height of the left side. So I'm going to go up to the function 0 and go straight across like that. Okay, so that's my rectangle from 0 to 4. And then from 4 to 8, I'm going to use the height of 4 because that's the left side here. And then make a rectangle like that and go there. Okay, so when I want to find this area is approximately, okay, so we're going to do base times height for each interval. So my intervals are 0 to 4 and then 4 to 8. Both of those intervals have a base of 4. Okay, so from 0 to 4, I have a base of 4, and I use the height at 0, f of 0. From 4 to 8, I use the height at 4, so we still have a base of 4, and I use the height at 4. Okay, so what that means, and then I just add those rectangles together, but what that means is I'm taking these two rectangles, which you can see are actually a pretty crappy approximation, and let's just say, okay, so f of 0 looks like it's at about 8, so we have a height there of about 8, and then f of 4 looks like it's roughly 3/2. Okay, so that's 32 and 6, so that's 38. Now, it's not great, but that is an estimate of this. But you might say, Boris, lefties are losers. What if we did this using the right endpoint? So what if we use the height at the right endpoint, at the right side of each interval? And this is another way that you could do it. It's called a right Riemann sum. So the same thing. I'm going to break this into an interval from 0 to 4 and then from 4 to 8. So from 0 to 4, now there's my first interval, there's my second. But for the first interval, I use the height at 4 and then go over and draw a rectangle. From 4 to 8, I use the height at 8 and then go over. That has no height, so that's just 0. Now again, we can see this drastically underestimates the area, but it's still a way to approximate, right? So I'm going from 0 to 4 and 4 to 8, and in each interval, I'm using the height at the right endpoint. And again, both of these have a base of 4. Okay, so that's 4 times f of 4, and then still a base of 4 times f of 8. So that's 4 times 3/2 plus 4 times 0. That gives you an estimate of 6. Well, it's not great, but these are both estimates. So this was a left Riemann sum, and this was a right Riemann sum, just using the height at both endpoints. Okay, and this idea of rectangle adding, again, this is called a Riemann sum. That's what we're trying to do. So basically the notation is we're kind of adding together a bunch of terms that have a function times some change in x, where that change in x is a base and the height of the function is a height. And a rectangle, of course, is base times height. Okay, so now you might say, hey, we just used two rectangles. What if we just use more rectangles, right? What if we used 4 rectangles for each one? So, okay, here we're going from 0 to 8. So that means that my intervals are going to be 0 to 2, 2 to 4, 4 to 6, and then 6 to 8. Okay, so each of those has a base of 2, because I'm still going from 0 to 8. So if I split that into 4 chunks, they each have a width of 2. Okay, so if I use a left Riemann sum, I'm using the height at the left endpoint of each of these. So I like to circle which ones I'm using there. So if I did that, let's see. So I'm saying let's use the height at 0 and go over 2. And then from 2 to 4, I use the height at 2, go over 2. The next one I use the height at 4, go over, and then the height at 6 and go over. Now, it's still not perfect, but I think we can see that as we're using more rectangles, we're going to get a more granular idea of what this area is. So when I do base times height and base times height for each of these 4 intervals, let's go ahead and work that out. So we're going to have 2 times f of 0, because I use the height at 0 here. And then from 2 to 4, I use the height at 2. And then 4 to 6, I use the height at 4. And 6 to 8, I use the height at 6. Okay, so that becomes 2 times 8 plus 2 times 4 plus 2 times 3/2 plus 2 times, and it's kind of hard to see, that's like roughly 1/2. Okay, so that's a rough estimate. So it's 3 and 1 and like 16 and 8, I don't know, it's like 24 and 4, it's like around 28. Not a perfect estimate. But again, you could also do this with a right endpoint. So you could use the height on the right side, and that's what a right Riemann sum is about. You use the height on the right side of each. Okay, so again, I'm going 0 to 2, 2 to 4, 4 to 6, and then 6 to 8. So 0 to 2, I go up on the right side of my interval, and then I draw that across. I go up here on the right side, and I draw that across. Go up on the right side, draw that across, and then there. So again, not a perfect estimate, but we're using 4 rectangles. On each interval, we're using the height on the right side. Okay, so let's see. So these each have a base of 2. I like to write that down, like what the base is for each of these, because when I do the base times height, it helps me realize, oh, all the bases are just 2. So this is just 2 times f of 2, and then 2 times f of 4, and then 2 times f of 6, and then crap, I ran out of room, but it's 0 anyway, 2 times f of 8. So that just becomes 2 times 4 plus 2 times 3/2 plus 2 times 1/2. So if you work that out, that gives you a value of 12. Okay, so let's talk about just a couple other things. First off, something obvious. If we use more rectangles, our estimates get better. And that makes sense, right? The more rectangles is going to be more accurate. If I just draw one huge rectangle, it's going to be pretty rough. But if I draw 10 or 20 or 50, it's going to give me a pretty good estimate of this area. So that's what this is. This is an estimate of the area under the curve. Anyway, as we go to infinity, this estimate will get infinitely good, and it will exactly match that definite integral you know about. Okay, I'll have some more in the first video. Thanks for watching this, and I'll talk to you guys soon.